This video will be covering the transformations unit and the first parts being translations. A translation moves or slides the graph to a new position vertically, horizontally, or both, right? So let's say f of x, right? So f of x is x squared. What if we did +1 or +2 or +3? Well, let's see. So if you were to do +1 or +2 or +3, it goes up vertically by however many units you specified. So in this case, 3 units. But what if you were to shift it down? -1, -2, -3, -4. It goes down the amount of units you type. So here, 4. We can denote the constant we add or subtract by as k. And remember, k only affects this graph vertically, right? You do +1, it'll move here, right? This is not an accurate graph, by the way. This is not an accurate graph. This is actually a really bad graph. Yeah, so +1, it'll shift up vertically. The vertex will shift up by 1. If you do -1, it'll shift down. But the vertex will shift down 1. So, yeah. So if k is negative, the graph moves down, and if k is positive, it moves up. Alright, so we know what happens when you add something outside the function. +1 shifts the graph up by 1, -1 shifts it down by 1. But what if we subtract, keyword subtract, inside the function? Not add inside the function, but subtract. So we're gonna denote the constant we're subtracting as h. Let's say h is equal to 2. So you get this open. It will actually shift it right by 2 because h is positive. So it shifts it right by 2. Even though the graph says -2, this negative is not h's value. It's just 2. Now what if h was equal to -2? So -2. Then if you subtract -2, it goes left by 2, which makes sense. But what you'd actually see it as is a minus, and a minus makes a positive. You'd see it as x plus 2. So even though the sign here is a plus, it's actually saying that 2 is a negative. If h is negative, the graph moves left. Okay, so let's say we did, if h is positive, so say that h equals 2, then the graph will be x minus 2 squared, and it's gonna go right. But if h is equal to -2, so y equals x subtract -2 squared, then it's gonna move left. And it will look like this, since a -1 times a negative is positive. -1 times -2 is positive 2. So, knowing that, what is the equation of the graph in blue? You have 3 seconds. 1, 2, 3. If you said y equals enter bracket x plus 3 end bracket squared, you would be correct. That is the graph in blue. So we know how to translate graphs now. So how do we put it down into notation? How do we get the mapping notation of it? It's called mapping notation. So xy, arrow sign. What affects x? Is it h or k? It's h plus h, comma, and what affects y? K plus k. This is the notation. The k value affects the y values, and the h values affect the x values. So look at this graph right here. This is the absolute value of x. I want you to tell me where these points went, okay? Of the original graph. So to solve this, you have to figure out what the translations are by tracking something that is like easy to track on a graph. So let's do the vertex. This moves 1, 2, 2 right, and then 1, 2, 3, 4, 5, 5 down. So k is equal to minus 5, while h is equal to 2. So we now know the h and k values. So the x value here is minus 2 plus h, which is 2, is actually just 0. And then the y value here is 2 plus minus 5, which is minus just 2 minus 5, which is negative 3. Okay, well, let's see, 0, negative 3. Okay, it tracks. X, so x plus h, y plus k. Well, the x value here is 0, 0 plus h would be 2, 2, and the k value here is negative 5, so 0 plus negative 5 would just be minus 5, and that's your new vertex, 2 minus 5. We did it. So that's the completed table. Now, what is the equation of the transformed function? We know that this is y is the absolute value of x. This is the black function. And we know the k and h value. So y is equal to the absolute value of x. And when you're horizontally translating, you subtract h from inside the function. So subtract h, and you add k outside the function. So y equals absolute value of x minus 2 minus 5. So f of x is transformed into g of x. So I want you to write the mapping notation for these points here. So here's something easy to notice. This point, or really any point, because they're all like so distinctive. So this point here, 1, 2, 3. So the h value is equal to minus 3, and the k value, let's see, 1, 2, 3, 4. K is equal to minus 4. Negative 3, 5 moves to negative 6, 1. Negative 6, 1. Well, that makes sense. If you do minus 3, you get negative 6. And if you do 5 minus 4, you get 1. Negative 1, 1 went to negative 4, negative 3. Negative 4, negative 3, which fits this value of the h and k's we've made. 2, 3 goes to negative 1, negative 1, negative 1, negative 1. 3, 2 goes to 0, negative 2. 0, negative 2, which fits our mapping notation k and h values. Now, what if we wrote the transformations in function notation? So if y equals the absolute value of x, so let's say y equals the absolute value of x, and we decide to move it left by 3, down by 2, and f of x is equal to the absolute value of x. So this works, but to write it in function notation, we'd have to do y equals f of the transformation within the function, x plus 3, and then outside the function, minus 2. Now, we don't use absolute value signs here because this is meant to just show what is happening to the graph. This is meant to show the changes it's undergoing. That's all. So it might look weird to look at, but just remember it like this. Y equals f of open bracket whatever's happening horizontally, end bracket whatever's happening vertically. That's all you gotta remember.